in this case, in the sleep example, we wanted to know if we had evidence that students are sleeping less than they're recommended to by the National Sleep Foundation. We want to know if we've got evidence that the true mean is less than 7. So when we look at our data, we say, is this small? Is this unusually small? Is 6.12? And when we look at this Z statistic, this 4.8 standard errors below 7, we say, is this unusually small? Is it unusual to get further than 4.8 standard errors below a mean? Okay. How are we going to measure if something's unusually small? Well, let's say someone brings in a phone. They buy a new phone, and the phone is like, it's like this big. Is that small? I'd say that's pretty small. I mean, here's my phone. So it's pretty small. The reason we would say that is unusually small is because you don't often see something that small or smaller. If someone's 2 meters tall, you'd say they're tall because you don't often see someone that tall or taller. If you want to say, is this unusually small? You say, well, how often would I expect something that small or smaller? We want to calculate this probability here, assuming this statistic comes from a standard normal distribution. Okay, we're saying that Z has a standard normal distribution, and we're saying how often would I expect to get something this small or smaller? And we're doing that to get a measure of how unusual it is to get something as small as minus 4.79 from a standard normal. So we are going to calculate this probability here as a measure of how small this is if it's unusually small. What's MATLAB want us to do? Should we use, we know a couple of MATLAB functions for doing this stuff. There's like norminv, normCDF. Which of those would we use here? Norminv is for finding the quantile, the value, so that you've got a certain area to the left. normCDF is for finding the area to the left of a particular value. That's the one we want, normCDF. normCDF of Z, where Z is negative 4.79. I ended up getting this area here. I ended up getting 0.00000008. So this is like really small, isn't it? It's like 1 in a million, a little bit under 1 in a million. This is about the same as if I had tossed a coin and got 20 heads in a row. 20 heads in a row. If I was tossing a coin saying, yeah, I'll let you pass the course if I get a tails, and I got 20 heads in a row. Honestly, by about 8 or 9 heads, you wouldn't be paying attention anymore. It'd be like, yeah, whatever. I've got something like slightly less boring to do with my life than watching you tossing heads over and over again. You're obviously not playing fair if you're doing that. 20 heads in a row, 1 in a million chance of something happening. You conclude that your data is not compatible with the null hypothesis. Our null hypothesis in this case is that the true mean is 7. Yeah, only 1 time in a million would you expect to get a class with a sample mean 4.8, standard errors below 7 if 7 was the true mean.